Hello guys, you're welcome to today's video. Today we will be talking about how to sign and send transactions to the blockchain using web3.js. For reasons best known to you, you might not want to work with the browser wallets. You might want to be responsible for the direct signing and sending of transactions. So without further ado, let's get started. You can open your Ganache and then have your truffle project initialized. I have my initialized already, but you can initialize yours like this. So to the code, my compiler version is 0.8.10, and that is the version I'll be working with. And so basically we will be creating a simple contract that changes the state. We'll be creating a simple function that changes the state of our contracts. So it's a simple it's a simple integer. So our function will be incrementing this integer. To the external. So it's as simple as this, and then also we will create an event to be emitted. So this event is just to show us basically that our transaction was successful. Then we emit it. So we have our contract up and running. So let's compile it to be sure we are good to go. Good. We are good to go with our contracts. So let's go and deploy our contract. So in our migrations folder here, we will create our migration. So you can come here, copy, so we are ready to deploy our contracts locally. So we have our deployed contracts. So in your directory you should have this build containing your state.json, your JSON file. So that JSON file contains the API that we'll be working with. So so you can install web3 like this, but I have my web3 installed already. So I have my web3 installed, and then this is how you can install the web3. So we come straight to our code, and I'll be creating a folder, source folder. I'll create a file in my source folder. You can name it anything you want. So what are the things that we need to get started with signing and sending our transactions to the blockchain? So we need to be connected to our blockchain node. We need our contract address. And then our contract ABI file. We need our contracts. We can sign, and then we can send. So let's just start with the first one. So to connect to our blockchain node, we need to import our web3. So to connect to our local blockchain node, we use a new keyword. So let's check our blockchain node URL. This is it. So this way we are connected to our blockchain node. So and the network ID that we work with is 5777. So with this network ID, we will be able to fetch our contract address. And to fetch our contract address, you don't have to memorize your contract address from this point of from this place. You don't have to memorize your contract address from this place. Our contract address is present inside the JSON file that's been given that web3 has, that Truffle has made available for us. So over here, I'll show you our contract address. So this is our contract address here. So we need to reference the network's key. Then from the network's key in its object, we need to reference our network ID. So you can see we have our contract address, and this is the same as our contract address. So we have our contract address. So we need to get our ABI, the ABI itself, because this ABI with our contract address is what will enable us to be able to get our contract. So in our ABI file, we need the ABI itself, and this is the ABI. This, we need to get all of these. Then our contract address. So we have our contracts. We've been able to fetch our contract using the ABI and the contract address. So now, how do we get to sign and send a transaction to the blockchain? So let's go to the documentation. This is the documentation to sign a transaction. So this is how we sign a transaction. .eth.account .sign transaction. So we need to initialize the transaction objects with the following: nouns, which is optional, the chain ID, which is optional, the destination. In our case, the destination is the the contract address, that is 2, and then the data is the encoded ABI of your function call. They call it the call data of the transaction. So in our own case, it is our function which is called increment. Then the value. So if, for example, we will be sending ether with our transaction, then we need to specify the value of our ether in a way. Then the gas price is actually optional. The gas, now you need to provide the gas. Your gas value should not be too low for your transaction to be rejected. You can set, just ensure that it is not too low. But this gas fee, ensure that you're able to set a limit. So once the transaction's gas fee is beyond what you set, the transaction is going to fail. So, and that is basically, so we can get started. So initialize our transaction object. Yeah. So before I do this, I would like to put this inside an async function, because I'll be working with promises. And I would like to get the address. The address is in for my Ganache. The reason for this is because I would like to add the from to my transaction, because I don't want my from to, I don't want the ether address to be specified as my from, because if you don't specify your from, the ether, which is address 0, is what to be like, is what is going to reflect in your transaction as your from. This is what I choose to set as my gas price, as my gas. And then the data, so the data will be our contract method. Let me split this. So these basically increments. So let's go ahead and sign our transaction. Then we need something, we need our private key. So to sign a transaction, you will sign a transaction with the private key. So the signer needs his private key to sign the transaction. So I will come here and import this private key. So before I log the signature, I would like to show something in the documentation, which is the return value. So with a successful signing, like once you're able to sign a transaction successfully, it's going to return the hash and then the RSV. So with the hash and the RSV and then this raw transaction, we can like compute, we can, it's possible for us to know the signer. So basically this raw transaction is what we are going to inject into our sent sign transaction function, which is this. So we take this raw transaction, is a string, this is the real signature, we take the signature, we inject it into this function, and then boom, our transaction goes to the blockchain. So let me log this out. If there are no errors, oh, look at me, dot sign transaction. Sorry, what is wrong? Oh, sorry, I didn't call my function. I didn't call my function. Look at me. Yes, so we have successfully signed our transaction. So we have our transaction hash, the message hash, and then the raw transaction string. So this raw transaction string is what we are going to put into our send transaction function. So it's high time we send our transaction. With the signature dot raw transaction. So this is what we are. Raw transaction is what we are going to put into the send signed transaction, basically. Dot then, sorry, not dot then, dot on receipt. So we want to print the receipt of our transaction. Oh, signature, it's okay. That was the mistake. Boom! So we have bloom. So we have been able to send our transaction to the blockchain. We've been able to send our transaction successfully to the blockchain. So let's go ahead and check our let's go ahead and check our events. So this way I want to make this in a sync. So this is how we get the events. We need to specify what events we are trying to get. Oh. Get past events. It's not a function. So let's come right to don't mind me. It's supposed to be contracts. So to get our events, sorry, from what block? To the latest block. Sorry. Boom. So we have our our events. These are the events. So so you see the total value is 4, the new value is 1, total value is 3, new value is 1. Let's see if, when I had 10 to it. So we have 14. So this way we've been able to successfully sign and send our transaction to the blockchain. So this is, it's so simple and it's so easy and simple. So if you enjoyed today's video, please don't forget to subscribe, and in subsequent time I'll be releasing more videos. So thank you for watching.